Hello friends, I am back with a new problem today. Again, this problem will be categorized as a problem which we can solve using Newton's laws of motion. Okay, so this is the problem statement. Find the acceleration of block A and B in below figure where capital M is greater than M. It means this mass is greater than this smaller mass. Okay, and all the pulleys are massless and the string is non-stretchable. That's given. So we need to find out the acceleration of block A and B. Okay, so just observe the motion. What will happen if this mass capital M, the body B is heavier than body A? What will happen is this body will start falling down, and since this body will start falling down, there will this string will pull this mass M upward. So B will go downward, A will start moving upward. That is going to the motion. Okay, so how do we solve such problems? You know, right? We need to draw the free body diagram of each component in the system. What is the system here? System is this mass block A and block B, and then this pulley along with this fixer. So this is the system. So out of these systems, if mass of the pulley, bigger pulley and smaller pulley, if you consider massless, then you can ignore them, right? So only effective components of the systems are A and B. So you need to draw the free body diagram of A and B. Okay, so let's solve the problem. Solution. Assume that A will move upward with an acceleration A, right? What will be the acceleration of B downward? Let's see. If this string, if this block moves by 1 meter upward, what will happen is, or let's say the other way. Let's say this block B moves downward 1 meter. What will happen is it will be like this. This is the pulley, right? So 1 meter, let us say this was the original position and this came down by 1 meter. So if it came down by 1 meter, this string and this string, both sides came by 1 meter, right? And if this both is coming by 1 meter, this will move upward by 2 meter. Getting? Because the extra string, only this string is available. So if it moves by 1 meter, this is mass will move by 2 meter up. So if the acceleration of this is a, this will become 2a. Or if this acceleration is a, then this will acceleration will become a by 2. This is important point. So just understand this. Listen to the video again and again, and then you will understand. Okay. So free body diagram of A. Let's draw the free body diagram of A. A. One more important concept here is let's think about tension. Since the string is massless, right? Let's see. So whenever the pulley is massless, right? Whenever the pulley is massless, the tension in both sides of the string will remain the same. So if this is the tension this side, then this side also it will be T, both sides. Okay, and and see, this pulley is fixed to the fixture, right? So this is T, this is T, and then this is passing through the center of mass, so it will not apply any rotational force to this one, to this pulley, but then it is still pulling this downward, right? So, but you can ignore the this rotational motion because this pulley is massless, and this string is attached to this fixed one. It's not attached to the pulley, right? So this is also a tension T, right? Because this pulley is massless, so both sides of this pulley will have the same tension. So T is here, T is here, T is here. It means this tension T is everywhere same in this string. Okay, so that's going to be the tension. So let's now understand the free body diagram of A. So A will become like this. Its mass mg downward, tension T upward, and then it is moving with an acceleration A. That's it, right? So let's apply the Newton's second law of motion for this one. T upward minus mg downward equal to ma, equ- equation 1, or T equal to mg plus ma. Okay, now let's draw the free body diagram of block B. Free body diagram of block B. What's going to happen here is this is the body with mass capital M, which is so weight will act downward, right? And then will be some tension here, right? Here also. Let's say this is T dash. So this T dash, let's assume for now this T dash upward. So T dash is upward. That's it. There are only two forces here. And then this is moving with an acceleration a by 2. We just already discussed this a by 2. So from again Newton's second law of motion, mg downward minus t dash upward equal to ma by 2. This is equation number 2. Now let's consider this pulley. This pulley, if you consider, this is massless, right? So force downward will be on this t dash because tension is always opposite to the opposite. It will be always in the opposite direction, right? So t dash, it will work on this block upward, but on the pulley it will pull it downward. That's how the tension works. That's the nature of the tension. And on this side we have T upward and T upward. Right? Since pulley is massless, though the pulley is moving downward with an acceleration a by 2, but the pulley is massless. So for a smaller pulley, since the pulley is massless, let's say T dash downward minus 2T upward equal to 0. Mass is 0, a by 2. This is 0. It means T dash equal to 2T, right? So put this value in equation number 2. It will become mg minus 2t equal to ma by 2. Put value of t in above equation. So value of t we already know, mg plus ma. So mg minus 2 times mg plus ma equal to ma by 2. It's just a matter of solving this now. So let's multiply it by 2 both sides. So it will become 2 mg minus 4 mg minus 4 ma equal to ma. Bring ma one side, 2 mg. So 2 mg 2m minus 4 is small m. Let's g common out, and then m plus 4m, right? We'll take a common. This gives a equal to 2m minus 4m divided by m plus 4m times g. So this is the acceleration of block A, right? Because we assumed block A is moving upward with an acceleration a, and so block B will be moving with an acceleration a by 2 downward. Okay, so uh, acceleration of A is 2m minus 4m by m plus 4m times g upward, right? Exactly whether this is upward or downward, that you can not tell right now. That will depend on the masses. What are the values of this capital M and small m? We'll take some example and then we'll see. But right now, when in terms of m, small m and capital M, it will be upward. Similarly, acceleration of A, B is a by 2. It means 2m minus 4m by m plus 4m times g downward, right? Now so these are the answers for now. For example, for example, let's take m equal to 4 kg and capital M equal to 5 kg. What is going to happen? Acceleration of A will be 2m minus 4 times 4 divided by m, right? Which is 5 plus 4 times 4 times g. How much this is? 5 to the 10, 4 for the 16, minus 6 above by 4 for the 16 of 5, 21 g. Cut it by 3, 3 7 the 21, 3 2 the 6. This is minus 2g by 7. What this minus sign means? Minus sign means is we assume the acceleration has upward direction. But for this value of small m and capital M, acceleration is coming as negative. It means our assumption was upward, but the actual acceleration is downward for these values of m. So acceleration A is 2g by 7 downward, right? Similarly, acceleration of B is half of this, right? Half of this a by 2. It means it will become g by 7, right? Um, and negative. This is minus 2g by 7, right? So it is negative. It means what it is showing is negative means it is opposite to our assumption. So our assumption was it is moving downward, but then actually for this value of m and m, it will go upward. So our assumption was b is downward, right? Minus g by 7 downward, but actually it will be now g by 7. If you remove the negative sign, it will be upward. So these values directions depends on your values of m and m. Example another example, for example 1. Now let's take another example. Why this scroll is not working? Okay, let's take m equal to 1 kg and capital M equal to 5 kg. What's going to happen now? Let's see. Acceleration of A is, what did you found? 2m minus 4m. A by 2. Did I do any mistake here? A equal to 2m minus 4m by m plus 4m g. That's correct. Acceleration of B is A by 2, right? So we'll have to have here G by 2. I missed this 2 and sorry for that. But final answer will remain the same, right? This answer will remain the same. So now A is a 2m minus 4m by m plus 4m. 2m minus 4m by m plus 4m times G. This is acceleration of A. So if you put these values, 2 times 5 minus 4 times 1 divided by 1 plus, no, this is 5, 4 times 1 into G. This is how much? 5 to the 10 minus 4. 6 by 9 G, which is 2 by 3G. Now this time it is coming positive, right? It means our assumption was correct. So this is upward, right? And then AB is AA by 2, which will become 1 by 2 times 2 by 3G, which is nothing but 1 by 3G. And this assumption our was downward, right? So it will remain downward because it's coming as positive. So our assumption was right. So what you are learning here is it depends on the masses. Masses. If this become too heavy, then this will start moving downward. And if this become almost equal to this m or little less than this m, then this will start moving upward, and then this will start moving downward. Okay, so was an interesting problem. I hope you enjoyed this. You learned a lot from this. Okay, so if you find this video useful, subscribe to the channel, like these videos, and write in the comment which other problem you want me to solve. Okay, then. Thank you. Bye bye.